Alright, today we're going to go over Chapter 3, which is Stoichiometry. This is really calculations with chemical formulas and equations. So most visual changes are going to indicate a chemical reaction is taking place. So some are more obvious than others, such as striking a match and you see the flame, or you drop a Mentos into a Coke bottle and you see it explode. But there's a number of chemical reactions taking place in our body right now, which are not so visual. Okay, and so the picture over here shown on the right is basically all the different chemical reactions that are taking place in our body at any given time. And so these are all different chemical reactions. So in this chapter, we're really going to examine the use of chemical formulas to represent chemical reactions, and on the quantitative information that we can obtain about the amount of substances involved in these reactions. And what we call this is stoichiometry, okay, and it represents a very important concept in chemistry. So you're going to need a very strong understanding of Chapter 2 in order to succeed in Chapter 3. So I really urge you to make sure you understand Chapter 2 at this point. So we can represent chemical reactions with a chemical equation. So if we know that different molecules are reacting with another molecule to form something else, we can describe this using chemical equations. So in these reactions, atoms are neither created nor destroyed, and so the chemical equation must be balanced. That means that the same number of atoms on the left side, over here, where we have our reactants, has to be the same number of atoms that are on the right side, which are our products. Okay? The number of atoms is obtained by multiplying each subscript in a chemical formula by the coefficient, okay, from the formula. So here we have H2. 2 is our subscript, which tells us how many atoms of hydrogen we have. And the 2 here says we have 2 molecules, which means we have a total of 4 hydrogen atoms, and we can see that here. 2 molecules of H2. So if we look at this closer, we can also see that there's 2 molecules of water in our product side, on the right side, and each is composed of 2 hydrogen atoms and 1 oxygen atom, right, shown here. And so we have 2 molecules of that. That means that in order to balance this chemical equation, that on the left side there has to be 4 atoms of hydrogen and 2 molecules of oxygen, or 2 atoms of oxygen. So to balance in a chemical equation, we need to determine the coefficients that provide equal number of each type of atom on the 2 sides of the equation. One key thing to remember is that when we balance the chemical equation, only the coefficients change, not the subscripts. So if we change the subscript, we change the composition identity. So we can change the coefficient, but we cannot change these subscripts. So if we know the formula of all the reactants and the products, which you'll learn how to predict what the products of a chemical reaction are in the upcoming lectures, we can then write the unbalanced equation, and we can use the coefficients to balance the equation as we just talked about. So there's really 4 steps that you can use to balance a chemical equation. You can also come up with your own. The first thing is to write out the elements present in each side of the reaction. Okay, so here we have methane plus oxygen, we get carbon dioxide and water. So what you need to do is first just write left side reactants, right? So that's everything over here. What do we have? We have 1 carbon, we have 4 hydrogen atoms, and we have 2 oxygen atoms. Right? On the right side, the products, we have 1 carbon, right? We have 2 oxygens here plus another oxygen, so we have O2 plus O, and we have an H2, right? So we write those down. The second step is we want to count the number of molecules, or count the number of atoms of each element present on both sides of the equation. So here we can look and we have 1 carbon atom. Here we have 4 hydrogen atoms, and here we have 2 oxygen atoms. Same thing over here on the right side. Third is we can add coefficients in the chemical equation so the total number of atoms in the reactants equals the total atoms of the products, right? Because atoms can't be created nor destroyed. So we recalculate and then we can check to see if all the elements are balanced. Right? And so what we find is if we add a 2 coefficient in front of this oxygen, that gives us a total of 2 oxygen atoms here times 2 is 4. And so over here we have the 2 oxygen atoms from here, and if we put a 2 in front of the water, we actually have 2 oxygen here, total of 4 atoms. So the number of oxygens are now balanced. Carbons we can see are balanced, there's 1 and 1. And the hydrogen, because we had 4 hydrogen over here, we had to put a 2 in front over here so that we had a total of 4 hydrogens as well. So when you balance chemical equations, it's all about practice, okay? It's a game. You basically just have to learn the skill and practice it and practice it and practice it And so I really encourage you to make sure you practice balancing equations quite often. So here we started with our unbalanced equation. We had CH4 plus oxygen gives carbon dioxide plus water. You can see that after balancing the equation, basically we have 2 molecules of oxygen, or oxygen gas, that react with one molecule of CH4 to produce 1 molecule of CO2 and 2 molecules of water. This is our balanced chemical equation. The one last note when you balance chemical equations and you write out these chemical reactions is you actually need to write the states of the reactants. When we talk about states, we're talking about the physical state, whether the reactant or product is a solid, a liquid, a gas, or an aqueous solution. And so we write that in parentheses right next to whatever the molecular formula is. Okay? It's very important that you write that down, and you'll learn to predict these or know what states they are in the upcoming lectures. So with that, we can start talking about some common reactions that we see in chemistry. Okay? And so we can look at the patterns of chemical reactivity. So the second part of this chapter is really focused on examining some frequently encountered chemical reactions. When we study chemistry, it's easier to understand general reaction types than just trying to memorize a number of reactions. So if you know the reactants, you should be able to predict the products. So the 3 types of reactions we're going to look at are listed here. The first is a combination reaction, and if you think about this, it means that 2 or more substances are reacting to form 1 product. The reaction is really similar to what happens when we use fireworks or flares. Okay? And in these reactions, it's a reaction between a metal and a nonmetal that's going to produce an ionic solid. So anytime you have these reactions, so here, which happens in a flare or firework, basically you have magnesium, which reacts with oxygen gas to form magnesium oxide. The way we know what this product is we form an ionic solid using the 2 reactants, magnesium and oxygen. And if you remember how we write those, Mg has a +2 charge, oxygen has a -2 charge, and if we swap those 2 charges, we end up with magnesium oxide. So if you're told the reactants of a combination reaction, then you should be able to predict the products and write the balanced chemical equation. One note is when you have a metallic oxide like calcium oxide reacting with water, you actually form a base, which is a hydroxide. So it's the metal hydroxide. Okay. A second type of chemical reaction commonly encountered is called the decomposition reaction. For these reactions, a single reactant will decompose to form 2 or more substances. Okay. And there's just a few really simple rules that if you just remember these, it'll help you predict the products of each of the reactions. So all binary compounds will break down into their elements. All metals are solids at room temperature. You should probably know that. All carbonates will break down to the oxide and carbon dioxide, and any kind of chlorate will break down to the binary salt and oxygen. And we see an example of each one of those shown here. So a binary compound like sodium azide basically can break down to sodium and nitrogen gas. Okay. Calcium carbonate forms calcium oxide and carbon dioxide, and potassium chloride will then become potassium chloride and oxygen gas. Okay, and so these are just common rules that you should memorize, practice, and help realize what type of reaction you have. The third is one that we actually looked at when we balanced chemical equations, was a combustion reaction. Okay, in these reactions, a flame is going to be produced as a result of a compound that reacts with oxygen and air. The most common combustion reactions that you're going to encounter are composed of only carbon and hydrogen, and these are called hydrocarbons. These reactions always react with oxygen, and they'll always produce carbon dioxide gas and water. Okay, and so here we have the methane gas, which we started with back in when we were talking about stoichiometry, reacts with oxygen gas to form carbon dioxide and water. So these are 3 of a few different types of chemical reactions that we're going to encounter through chapters 3 and 4. And what you should be able to recognize is if I give you one of these reactions, you should be able to tell me if it's a combustion reaction, a decomposition reaction, or a combination reaction. Or alternatively, if I give you the reactants, you should be able to predict the products from that reaction. And so this is practice. It's learning the rules and being able to apply those rules to some complex problems. So next time we'll pick up the other part of chapter 3 in the next video.